Let's talk about solving systems of linear equations in two variables. What does that mean? A system of linear equations is when you have two or more linear equations and you're trying to find what value or values make both of these true. You'll usually see it written with a curly brace on the side, and that shows they go together. There's different ways of solving this. You can solve them graphically, and you can solve them algebraically. There are two different methods for solving them algebraically: substitution or elimination. No matter which of these three methods you use, however, you'll get the same answer. Let's take this example. If I told you that 3, 4 made these equations true, that is, it solved the system of linear equations, how could you prove that? Well, what you would do is you would take each equation and test this point. In equation 1, I would have 3 plus 4. That is, I'm substituting x is equal to 3 and y is equal to 4. Does that equal 7? Why, yes, it does. Let's look at the second equation. 3 minus 4. Does that equal -1? And yes, it does. So the point 3, 4 does solve the system of linear equations. Let's look at how we come up with the answers. If I wanted to solve this by graphing, I would graph the first line and then the second line. I would graph these both by intercepts, since they're in standard form. If I let x equal 0, I see that y is equal to 7, and this is the point 0, 7. If I let y equal 0, then x is equal to 7, and this is the point x, 0. For the second equation, let me write this one out. If x is equal to 0, negative y is equal to -1, or y is equal to 1. So that's the point 0, 1. If, however, y is 0, then we see that x would be equal to -1, or that would be the point -1, 0. I would connect the dots, and if I had better graph paper, I could see that this point of intersection is the point 3, 4, and that's the solution we just verified. There's two situations when we graph that will seem a little bit different. The first is my two equations could be two parallel lines. In this case, there would be no solutions because parallel lines never cross. You could also end up with a situation where one line lands right up on top of the other line. In this case, there's an infinite number of solutions. Because the two lines are exactly equal, every point along that line is a solution. But normally, we will get one solution, like in our first example. Another way of solving a system of linear equations is by substitution. This is one of the algebraic methods, and it works very well if you already have one variable in terms of another variable. For instance, with this system, y equals -x minus 1. So what I can do in the second equation is anywhere I see y, I'm going to put parentheses, -x minus 1. So all I've done is substituted the value y with -x minus 1. And then I'll go ahead and solve for x. I'll use the distributive property, I'll combine like terms, and then I'll use the additive property of equality to subtract 3 from both sides, and I get 7x equals 21. Then I'll use the multiplicative property of equality, divide both sides by 7, and I get the value that x is equal to 3. Now I need to go ahead and find the value of y. Well, y is just equal to -x minus 1. If x is equal to 3, then I find that y is equal to -4. So the solution to the system of linear equations is simply 3, -4. Again, we could test this by taking the 3 minus -4, plugging that into the first equation, and plugging that into the second equation. The other method is another algebraic method, and this is the addition or elimination method. The trick to using this is to line up the equal signs and to put the equations in standard form. Standard form is when you have a times x plus b times y equals c. That is, the x and y's are on the left-hand side of the equal sign and the constant is on the right. Let's look at an example of this. Here I have a system of linear equations. The equal signs are already lined up and both equations are in standard form. The next step is to multiply one or both equations by a constant in order to eliminate one variable. For instance, looking at this system of linear equations, I can see that if I multiply the second equation by -5, then what I will get I'm going to first write the first equation again, but the second equation then becomes negative 5x plus 10y equals positive 15. Now when I add these two together, the x's are eliminated because 5x minus 5x is just equal to 0. So I end up with 6y equals 24. I divide both sides by 6, and I get that y is equal to 4. Again, I need to find the corresponding value for x, so I'll go ahead and use the first equation, but instead of y, I'll write the number 4, and when I do this, I find that 5x equals 25, or x is equal to 5. So the point 5, 4 solves this system of linear equations. Again, I've gone through these examples pretty quickly, but this should all be review for this class. There's plenty of practice with the homework, and if you have any questions, please don't hesitate to email.